So 4, 6. So this continues. What was it initially? 4, 1, 2?
4.5.
That was 4.5 when I gave you these?
Yeah.
Okay. So it was 4.5. Okay. So the top graph we did was sine, and your sine looks like this, correct?
It does.
Okay. The domain was
All real numbers.
all real numbers.
Yeah.
The range was -1 to 1.
Yeah.
Max, I don't know if you wrote it on there, but the max is 1 and the minimum is -1, right? Okay. So we are going to throw on there, well, what's the reciprocal of sine? Cosecant. So we're going to put cosecant on the same graph. Now, if you had a color pencil, maybe you want to trace sine real quick. Maybe you want to trace sine real quick in a pen, so you know the difference.
I'm a one color type of guy.
Okay. So what is the reciprocal of 0?
0.
Anybody?
Undefined.
Undefined,
Oh.
correct?
Yeah.
So if the reciprocal, because sine of 0 is 0, yes?
Yeah.
So the cosecant at 0 is undefined. Well, when something is undefined on a graph, what does it make?
Streak on that.
Just across, is it just right along the x-axis?
What's that thing called when it was undefined? Remember when we did rational functions and the denominator made it undefined? So you had 0 in the denominator, and it was a vertical asymptote.
Oh.
Okay, when something is undefined, it is a vertical asymptote, correct? That is, you need to know that. Because any function I give you, if it is undefined, it is a vertical asymptote.
Well, I do now.
Okay,
I remember
well,
the asymptote.
so when we had a vertical asymptote, we made slanted lines, right?
Yep.
Can you see the green?
Yeah, I could see it.
Doesn't look
I don't know about
green,
anybody.
Can you see it? Can you tell the difference from the other?
I can tell.
Yeah.
Okay, so that's a vertical asymptote, right? So anytime that sine is 0, cosecant is going to be undefined, isn't it? Isn't it?
Yes.
So is there another vertical asymptote on here?
Yes.
Where?
At pi.
At pi?
Yeah.
Because when I reciprocate 0, I get what? Undefined. This goes back to our exact values that you guys should still be working on.
What?
This goes back to our exact value quizzes that we did. Okay, is there another 0 on here?
Yes.
Where?
Negative pi.
Negative pi. Because anytime I reciprocate 0, I'm going to get undefined, aren't I?
Would there be one at 2 pi?
Mm-hmm. And where else?
Negative 2 pi.
Okay. Anytime sine is 0, cosecant is going to be what?
You're undefined.
Undefined. Because when you reciprocate, 0 is like 0 divided by 6, right? When you reciprocate 0 divided by 6, you get 6 divided by 0, which we should all know we can't divide by 0. So we have all these asymptotes, right?
Yup.
And we're building this graph off of reciprocating things, yes?
Yeah.
What else would be easy to reciprocate?
Graph.
What other point on this graph would be easy to reciprocate? The min and max, right?
One of those numbers.
Okay, what is the reciprocal of 1?
1.
No, the reciprocal of 1 is
0.
1. What's the reciprocal of -1?
Negative 1.
-1. Okay, what's the reciprocal of -1 over here?
Oh, negative 1 over there.
And over here?
Negative 1 over there.
How about 1? Okay, well, when you reciprocate 1, okay, that gave us, I don't know, Well, we also had these things here, and I probably should have done it better. My sign better. This was a half, right? Pi over 4. Not pi over 4.
That is half.
The sign at pi over 6 is a half, yes?
Yeah.
So it's over here somewhere.
Mm-hmm.
And what's the reciprocal of a half? 2. Yes?
Yeah.
So this point that you have your half, because I think you guys have a better half written on there, don't you?
I do.
Okay. Reciprocate it up to where?
2.
2. We're just reciprocating values. The reciprocal of a half is 2. Well, what other value could we reciprocate?
Negative.
Negative half, and that would be what?
Negative 2.
Negative 2. Wait, that's not negative half. I put it in the wrong spot.
Yeah, you did.
I'm sorry. This is positive a half, yes? So
Yeah.
it'd be what? 2?
Yeah.
This one over here is negative a half, so it'd be what? Negative 2? And this one's negative a half, so it'd be what? Negative 2? I meant to put it here and I put it there. Sorry. What else, other points can I reciprocate?
The other side.
The other side.
It's making. It's not working.
So then, negative half, so it's what? Negative 2. Negative half, so it's negative
2.
2. And then I've got positive a half, so it's what? 2. And then positive half, so I get 2. So, if I look at this pattern, between negative 2 pi and negative pi, everything is positive, yes?
Yeah.
So, when I reciprocate a number that's less than 1, do I get a number greater than 1?
Yeah.
Yeah? So, like 1/3 less than 1, what's the reciprocal 1/3? 3. 1/12 is 12. So, this graph in the sine, this section goes down, but in cosecant, it's going to go what? Up. Do you see that? You have 2 points, comes down, and goes back up. Is it going to ever touch the asymptotes? No. It's going to get close to them, but never touch them. What's it going to do in the next? From negative pi to 0. It's going to go where? Down. Again, because everything between 0 and negative 1 is going to be less than negative 1 when you reciprocate it, isn't it?
Yeah.
So what's going to happen between 0 and pi? It's going to go what? Up. So if I think about it, it just reflects off of the max and min, doesn't it?
Yo.
And then over here, it's going to do what?
It's a weird graph.
So if I took away sine, you would have all these independent what shapes? No. Parabola. Thank you very much. If I took away the red sine function, I would have all these independent parabolas. Is cosecant a continuous function?
No.
No. I have to pick up my pencil or pen or whatever repeatedly, don't I?
Yeah.
Okay? Sine was a continuous function. The domain was all real numbers. Is the domain of cosecant all real numbers? No. We have an asymptote at 0, at pi, at 2 pi. What would be the next one? 3, 4, 5, on and on, right?
Yep.
Negative pi, negative 2 pi,
Negative.
3 pi.
Yep.
So my domain here would be x such that x is not equal to Now, the first time it is undefined is at 0, but you can't start with 0. That's kind of weird. So the next time it's undefined is where? Pi. And then how would you describe the next one?
2 pi,
And then,
3 pi.
4 pi,
so could I just put pi in?
pi n.
Yep.
Yeah.
At every increment of pi, because if I plugged in 0, I get what? I get 0, and does that show that's undefined there?
Yeah.
Yeah. Okay.
Wouldn't it be plus or minus pi?
You could, you could, and I struggle with this. I'm going to tell your book just says n. There's times I put plus or minus because when n is the number of times things happen, and things don't happen negative times, do they? So I personally write plus and minus pi n. Your textbook is not. It's going to be implied that n can be negative. So I am not going to force you to do that because I know there's more math instructors than not that just leave it as pi n. But technically, yes, it is plus or minus.
So if we put plus or minus,
I am not going to count it off. Hey, so range's a little trickier. Over here, it bounced between -1 and 1, yes?
yeah.
But this one doesn't bounce between it, it bounces off of it, right? So it's not going to be an and situation like this, it's going to be a what?
Union?
Nope. This is the union, this would be and. It's going to be an or situation. So in this first chunk, or when it's positive, it's from 1 to where?
2, 2,
Where's it going?
up. Infinity.
Infinity, right? So it's going to be y is, I'm going to do my less than first. Less than or equal to what? Where's it less than? That'd be down here, right?
Yeah.
So what's my max?
1. -1.
-1. Or it bounces positively and y is greater than equal to what?
1.
1. You always just put your negatives first. So, do you see how I turned my range inside out, basically? My range did bounce from 1 to -1 to 1 when it was signed. But now I cut all those pieces. I cut it at every pi and took the graph and just did what?
Lift it up.
I flipped it up. I reflected it off that max or min. So when I ask you to draw me the parent function of secant, I'm going to ask you to write 1 revolution. Okay? 1 complete cycle, and we'll talk about that in a second, of this function. So I would 0 to 2 pi, sketch myself a sign, then put how many asymptotes? 1, 2, 3. And off my max, I do what? Reflect up. And off my min, do what? Reflect down. Because that's what reciprocating a half does. From a half, you get what? 2. From negative a half, you get -2. You're just reciprocating the values in there. Now, the other thing we had on here, we probably had the period of sign, didn't we?
Yeah.
Okay. The period of sign is what? 2 pi. What else did we have? Did we have the amp?
Is
Yeah.
1.
So the amp is 1. Anything else?
No.
No? Okay. So let's talk about the period in the amp of cosecant. Again, the period is the amount of x-axis that it takes for me to repeat this.
5.
Well, if I go from pi, I get all the positive. Yes?
Yeah.
Or all the negative. Don't I need both?
Yeah.
So it's,
Positive or negative pi.
well, I just want the period is what? 2 pi.
Oh.
Okay? The period, this is 1 pi from here to here. Yes? And then another pi from here to here.
Yeah.
Or could I go from here to here?
Yeah.
That's still how far? 2 pi. How far is it from here to here?
2 pi.
2 pi. The period is still 2 pi. Because I still need a distance of 2 pi on the x-axis to give you all the positive and all the negative values, correct? But now the amp. Amp, what is the definition of amp?
The max or min?
No.
The graph between the max and min.
Access.
The difference from the axis of the curve, okay, to the max or the min. Yes? Where's the max?
Infinity.
Where's the min?
Negative.
So does it have an amp?
No.
No.
NA?
There's no, yeah, NA is really, no amp really doesn't fit the situation because no amp to me is a line, correct? This isn't a line. It's just I can't ever get
A max.
a max or a min. People will tell you that it's infinity. No, its limit is infinity. That's not its amp. An amp is a distance and you can't measure infinity. Does that make sense what I'm saying?
I understand.
Thank you, Austin. Questions about this graph? How did we make it? All by itself?
No.
We reciprocated the sine curve.
Yeah.
Okay? You will need to know what this looks like. You will need to draw me, on your next test, I will ask you to draw me a sine, a cosine, a secant, a tangent, a cosecant. I think I meant sine, cosine, secant, cosecant, tangent, cotangent curve. Well, you should already be able to give me a sine one, correct?
And a cosine.
And a cosine. So now we're just adding.
I just have a really quick question for Lynn. Hey, do you have the card reader? Oh, yeah.
Okay, so let's go on to secant.
Yay.
Oh, I apologize for not bringing it back, but I used it again this morning, so it's okay.
Okay, so how are we going to build secant?
Talking.
Same way we did with
The same way we did with cosecant, right? So we're going to start by putting in asymptotes. Where do asymptotes go?
on the zero.
On the zeros. So where it crosses the x-axis. So it is not 0, pi, 2 pi. It is where?
Pi over 2.
Pi over 2.
3 pi over 2.
We're just reciprocating 0, right? So on cosecant, we had 5 asymptotes between negative 2 pi and 2 pi. Here we have 4, but they still both all went at the zeros of the function, correct?
Mhm.
Then what did we do?
The min and max.
The min and max, we reciprocated them. Well, we'll start all the way over at negative 2 pi. So the reciprocal of 1 is what?
1,
1. The reciprocal of negative 1 is?
negative 1,
Reciprocal of 1 is? 1. Negative 1 is?
Negative
And then
1. 1.
and then we reciprocated a half, didn't we?
Yeah.
So reciprocate your halves. Half goes to 2. Negative half goes to negative 2. Just find where it crosses the grid and like add a half and reciprocate it. The only thing I'm going to give you a hard time about not getting exact is 1 and negative 1. Guess if I happen to give you graph paper, but I'm not going to give you graph paper to reciprocate your half. You should be able to bounce off a 1 and negative 1, right? Oops, I didn't go up far enough, did I? Probably would have helped me out if I would have labeled my y-axis like I'm supposed to, right?
Maybe would have helped you out.
Okay, I've reflected everything. Now I just draw a bunch of what?
Parabolas.
Parabolas, thank you. Not lines.
What is the parabola missing? It's a line.
Evan, how do you not?
It's an arc.
But how do you make it with two lines?
I think we're trying to be smarter than this, Mick. It is impossible.
It's impossible. One man smarter than this man.
I am
The only person smarter than this, Mick, is Braun Forney, okay?
That's what I'm hearing.
Okay, does your graph basically look like a cosecant graph?
No, it looks weird.
Yes.
All
yes,
odds are the
yes.
same thing. Just flip it over.
Yep.
Just make
All day long.
our graphs look very similar.
So when I'm telling you that I expect you to draw the parent function, am I expecting an over amount of stuff here?
No, ma'am.
Yeah.
No. Okay, so the period of cosine was pi, the amp was 1, max and min, right? Okay, so domain. Well, our domain is going to be different than cosecant even, isn't it?
Yeah.
Because at cosecant, all my asymptotes happened at pi, correct? But here, what does the first asymptote happen at?
Power 2.
Pi over 2. And then the next one at what?
3 power 2.
Now, is that, how far away is that from each other?
1 pi.
1 pi. So we write it as x cannot equal pi over 2, because that's the first time it happens. And now Isaiah, I will put plus or minus pi n on this one, because I have the pi over 2 in front. Okay? So I start at pi over 2, yes? And I either add a pi or subtract a pi, and I'm going to hit every asymptote from there, aren't I?
Yeah.
So what is my range?
Shouldn't that be the same?
Yes, that is the same. The range is the same as cosecant. It's going to be y is less than equal to negative 1 or y is greater than equal to 1. The range is the same. Period is how far?
About
Well, let's think about it. From here to here is how far? From negative pi over 2 to pi over 2. That's 1 pi, and there's all my positive, yes?
Yeah.
From from pi over 2 to 3 pi over 2 is how far? 1 pi. So I have 1 pi plus 1 pi is 2 pi. And the amp is
Amp would be
NA. It's not applicable. Now I will tell you, most times they show you this graph like this. Okay? Now, right here is 2 pi. Do you see the whole period of cosine?
yeah.
Yes? Do I have the whole period of secant?
yes.
Yeah, I've just got half of my positives here and half of them where? There. But do I still have all of them?
Yes.
Yes. Could I cut it from here to here?
Yes. No.
Yeah.
Yeah.
That's
But it covered both bases.
Do I have all the positives? Yes. Do I have all the negatives?
yeah.
Yes, I just have them in 2 different spots. I like to do consecutive. I like to go from here to here. But I see this one because you clearly see the cosine curve in it. Yep. Okay. I'm not going to tell you which one you have to show me. I'm going to say, give me one period. So if you choose to do it from here to here, that's fine. If you choose to do it from here to here, is that okay also?
Yeah.
Yeah. If you want to do it from here to here, I don't care. As long as I have one full period.
I don't want to.
Tough. Okay.
Give me 2 periods.
So we've done sine, cosecant. If you give me 2 periods, I mark off because I asked for how many? 1. Okay. Sine, cosecant, cosine, secant. Now we got to do what?
And
Tangent and cotangent.
can I go get a box of tissues?
Make, not get a box of tissues.
Okay, so tangent, we got to start off with our exact values and what we know. So at 0, what is tangent? 0. Okay, I know that one, right? What's another good exact value for tangent we know?
1.
1. So that's at where?
Pi.
No. Tangent is 1 at what? No. Tangent is opposite over adjacent,
Yeah.
x over y.
1, 1.
Where is x over y the same?
0.
Nope.
Pi over 2.
Nope.
I don't know, Miss Meg. You tell me.
2
I'm-
pi.
I'm not going to tell you. What triangle has the two legs the same length?
45.
45, 45, 90. So where is it 1 at? Pi over
Pi over
4.
Yeah.
Okay, so if this is pi over 2, this must be what?
Pi over 4.
Pi over 4. And we're going to name this 1. So this is what?
Pi over 4.
Pi over 4. Okay. Well, what happens at pi over 2 for tangent?
It,
It's 5 to
reaches low.
Guys, when I say pi over 2, you need to be thinking about your x and your y point. What is your point at pi over 2? On my circle, what's my point up here?
Up there?
Hmm?
90 degrees.
About 90 degrees.
What's the point?
1, 0. 1.
0, 1.
It is.
It's
It
0,
is
1.
0, 1.
Okay, I'm just drawing
Yeah.
it. This point is 0, 1. So what is the tangent up there?
Undefined.
Undefined, so that is a what?
asymptote.
That is an asymptote.
So we go on cross these lines.
Yes. What do we do the same with the rest of those?
Okay, so we're going to keep going. So 3 pi over 4 over here.
3 pi
Mhm.
over 4.
It's still my 45, but it's not going to be positive 1. It's going to be what?
Negative.
Negative 1. So at 3 pi over 4, I'm going to put it at where?
Negative 1.
Negative 1. What happens at pi? What is the tangent at pi?
0.
0. I told you your exact values wouldn't go away. So then 5 pi over 4. No. That's 45 in the third quadrant.
So negative 1.
Not negative.
Positive.
Positive because both x and y are
Oh,
Negative.
Yeah.
3 pi over 2 down here. What's tangent?
It would be undefined.
It'd be undefined because that point is what? 0,
1.
negative 1.
Yeah.
So undefined is a what?
It's a asymptote.
Asymptote. Asymptote.
Okay, you guys are weird. Okay.
Shit, you weird.
Let's see. This was 5 pi over 4, so this one probably be about 7 pi over 4, right?
Yeah.
So 7 pi over 4 is the 45 in the fourth quadrant. So is it positive or negative?
Negative.
So it's negative 1, right? And then 2 pi is
Just be 0.
0.
Yay.
Okay, let's go backwards. So now I'm going this way, right?
Negative pi over 4.
So negative pi over 4,
That would be negative.
negative 1. We were just there, weren't we?
Yeah.
So it'd be negative 1.
And then it'll be an asymptote.
So then it's going to be an asymptote at negative pi over 2.
And then 3 pi over 4 would be a positive.
It'll be a positive 1. Negative pi is a
0.
negative 5 pi over 4. So back up here. It would be a negative 1. Negative 3 pi over 2.
An asymptote.
An asymptote.
And then 0. No, not 0. So it would be a positive 1.
So then you're back at
Positive.
negative 7 pi over 4. So you're positive because you're back in the first quadrant.
And then it will be 0.
And then it would be 0. So how is this going to work?
They're just
It's gonna look like the thing.
It can't be a straight line because I can't run into an asymptote, can I?
No, ma'am.
No. So I have to come near the asymptote.
It's gonna curve a little bit like those cube graphs.
Sorry.
And then it's going to go up. So then what's it going to do here?
Hey, where
Oh,
did that
yes.
start?
There you go.
I had my circle showing before. And is this pattern going to keep repeating itself?
Yeah.
It's much easier to draw them when you're not trying to go through the points.
Sickle mode.
And at the end, it's just up. And it's just what? Down. They are continually increasing. They do kind of dip a little bit more than I've drawn them. If you see them, they kind of looks like that. But it is continually increasing.
I can't see what that looks like. Miss May.
There.
Ooh, curvy.
Yep. They need to be a little bit more curvy. I didn't.
got mine pretty curvy.
Us did.
Those look like those
That's a very good example.
cube graphs. Isn't that what it
Yeah, it does kind of look like a third degree graph, or an odd degree of graph. There. My concavity is not right and it's bugging me. There we go.
Do we gotta write anything?
Okay, yes, we do. Period. Oh, domain.
I thought we were done. You didn't put tangent at the top.
Yeah.
Oh, tangent. The blue is tangent.
I don't know what you're talking about. Such that x is
What's x not equal to?
not equal to pi over 2.
Pi over 2 plus or minus pi n?
Yeah.
Okay, what is that the same as?
The cosecant.
The
Wait,
secant.
Secant, not cosecant.
Range. We're going to finish this one. Range.
It would be the same.
Nope. Range is all real numbers. It extends. Period.
2 pi.
Be careful.
Pi.
It's only pi. Because if I cover up everything else, do I see the whole thing right there? Yep. And that's from negative pi over 2 to pi over 2. So that distance is pi.
Amp is not
Amp is non-applicable. Okay, I would like you on your assignment, I think it's just finding values using these graphs. You do not have a cotangent graph yet, but you can do everything but the cotangent questions. It's 49 through 56. You're going to say, where is tangent 2 at? And you find that angle. Okay? It's practicing those exact values. We will go over cotangent and any questions tomorrow on that assignment. It's just barely just to get to know them.
What?
And we will finish cotangent.